Four functions in scientific notation: add, subtract, multiply, and divide. Before we get too far, let's remember about place value. Scientific notation tells us a different place value. That's not the ones place. The 3 is in the thousands place. The 5 is in the 10,000s place. The 10 to the fourths are here. What's next to it? The 10 to the thirds place. And if we need to keep going down, the 10 to the 2s, the 10 to the 1s, and keep going. So let's get ready to add. Which of these two numbers is bigger? It's not the 8. That's a trick. 10 to the fifths are way bigger than 10 to the fourths. Give myself a little more room. What place is the 3 in? Ten to the fifths. What place is the 2 in? 10 to the fourths. Where does the 8 go? Is it in the 1's place? No. It's in the 10 to the 4's place. Does it go under the 3? No. It goes under the 2. Where does the 1 go? Next to the 8? Probably want a placeholder 0 in the 10 to the 3's place. I've changed my 8.1 times 10 to the 4's to line up with the 10 to the fifths. That moves the decimal point and changes its name. But you know how to add decimals, right? .01 times 10 to the, is it 10? Is it 25? When we add ones and ones, we get ones. When we add tenths and tenths, we get tenths. When we add thousands and thousands, we get thousands. So when we add 10 to the fifths and 10 to the fifths, they stay 10 to the fifths. The place value's still the same. A trickier example. But the same idea. Which number's bigger? 10 to the 7th is bigger. Leave a little room. What place is the 9 in? It's in the 10 to the 7s. The 8 is in the 10 to the 6s. And if I need more, on any side, we could keep going bigger or smaller. Where does my 5 go? It's in the 10 to the 6's place. 8, 7, 6. The 5 goes in the 10 to the 6's place. The 2 goes right next to it. And we add. Now I get 10.32 times 10 to the 7th. But that's wrong. The answer's not in scientific notation. this number is bigger than 10. Let's fix it. 1.032 times 10 to the, what place is my 1 in? 10 to the 8th place. Now we've got our real answer written in scientific notation. Subtracting's the same thing, so I'm not even going to do an example of that. But I will do an example of multiplying. Multiplying scientific notation numbers is way easier. Look, it's all multiplying. We can do multiplying in any order we want. We could put the leading numbers together, we could put the 10 powers together, and that's easier to multiply. What's 2.1 times 3? 6.3. What's 10 to the 5th times 10 to the 4th? Is this where we add or where we multiply? 5 tens and 4 more tens, that's 9 tens. 6.3 times 10 to the 9th. Easy. So of course I'm going to make it harder. Oh, huge numbers. But let's put the same kind of numbers together. 4 times 8. And all of our tens. 4 times 8 is 32. And how many tens? Do we multiply? Do we add? 20 tens, take away 3 tens, is 17 tens. But this answer's not right, because it's not in scientific notation. That number is too big. It should be 3.2 times 10 to the 1 place bigger, 18. Turns out dividing's not any tougher. But we'll do an example anyway. 2.1 divided by 3, that's like 21 divided by 3, is 0.7. 10 to the 5th divided by 10 to the 4th, when we were adding, when we were multiplying, we added the exponents. When we're dividing, we subtract. 5 minus 4 leaves 1 left over. But our answer's not in scientific notation. We need to move it 1 place. It was 1 place smaller, 1 smaller than 1, 10 to the 0. Yeah, that's really just 7, but if our problem was in scientific notation, our answer should be in scientific notation. Have at it.